This is Physics 2 Lab 1, Charged Tapes. Introduction. Purpose. The purpose is to prepare charged pieces of tape and to observe their interactions and transfer of electrons. Models with the fundamental physical principles. Calculate the gravitational force using Newton's second law, which is force equals mass times acceleration, and calculate the electrical force using Coulomb's law, where F equals K times Q2 over D squared, where E equals 1.6 times 10 to the negative 19 C, which is the electrical charge. Experiment setup. Assumptions. Ignore air resistance on the moving tape. Treat the long tape as though it were point charged, with the charge concentrated at the center. The U-tape made had the same amount of charge evenly distributed along the length of the tape. Initial conditions. The U-tape acquires its charge because an ordinary object can acquire an excess or deficiency of a negative charge if it is rubbed, pulled apart, or touches another object. U-tapes are made by sticking one piece of tape to the table and putting another piece of tape directly onto the piece of tape and quickly ripping the top piece of tape, the charged U-tape, off. Observations for prior knowledge. The U-tape was attracted to the skin on a hand, which is a neutral object. A pen was rubbed on a piece of cloth, giving it a negative charge, and the U-tape was attracted to the negatively charged pen, meaning that the U-tape is positively charged. Two similarly charged U-tapes repel. Experiment setup. Initial conditions, both tape A and B are charged U-tapes with positive charges. Tape B is a system and tape A is the surroundings. Process. Both U-tapes are made. Tape B is hung between two books while tape A is held under it, as shown on the right. If there is any movement or repulsion between the tape, the distance tape B moved will be recorded. Prediction. Since the two pieces of tape will have the same charge, they will repel, and the tape B will move upwards. Experiment results. Similarities and differences of results. Since tape A and B have similar charges and similar charges repel, tape B repelled and moved upwards away from tape A. This is because of the ripping of the piece of tape from another piece of tape and transferring electrons. Measurements. We found the length of tape to be 8 inches, mass of the tape to be 0.203 grams, and distance moved between the tapes is 1.5 centimeters. Computational model calculations to find the magnitude of the charge of one piece of U-tape. First, we have to calculate the magnitude of the gravitational force on tape B using Newton's second law of mass times acceleration, where the acceleration is g. Calculate the next force acting on tape B using the gravitational force and Coulomb's law. We then use substitution and rearranging by finding that F electric equals negative F gravity. Measuring the distance between tape A and tape B before tape B begins to float. This distance was 1.5 centimeters. Then we determine the charge on tape B by plugging D into the rearranged equation. Then we determine the number of electrons on tape B by dividing the total charge of Q by the charge of one electron, which is 1.6 e to the negative 19, 1.6 e negative 19 C coulombs. Code. Here is the code using the constants of E, the mass, force of gravity, and D, and then the calculations to find the force of gravity, the force of electric, and the square root, and the number of electrons on tape B, where the results is the magnitude of the charge on one point of tape is 2.23 to e to the negative 7 coulombs, and the number of electrons on tape B is 1.395 e to the positive 12. Discussion. Possible sources of error. The calculated mass isn't the mass of the tape. Measured distance isn't accurate because of the difficulty to measure the distance between tapes, and the tape loses their charge after being handled or making contact with your hands or other objects. So the pieces of tape could have different values of charges based on how much it has been touched. It is important to handle the charged pieces of tape as little as possible to make sure that they keep their charge. What if electrons have positive charge and the protons have negative charge? The electrons across protons would swap charges, but the observed interactions would stay the same, since they would still have the opposite charges to the objects they are interacting with. This means the tape would still be attracted to the object. Conclusions. Objects with the same charge will repel, and objects with different charges will attract. The amount of objects charged and interaction between charged objects can be seen with household objects. Coulomb's law can help measure these forces with the help of Newton's second law, and this shows that these laws and forces are applied and experienced by everyday items.